This is the second video on dosage calculation. In this video, we're going to learn about the dosage formula. Now, when you talk about a strength of the drug, strengths can be written in many different kinds of units, but this will tell you how much drug is in a given quantity. For example, this is saying that there's 400 milligrams in a tablet, or here they're saying there's 10 milligrams in 1 milliliter. Notice there's no number here, but if you don't see a number, it's understood to be 1. You know, this one here is a new one, maybe to you, is milliequivalents. Like there's 10 milliequivalents in 15 milliliters, or this last one, 2 grams, 100 milliliters. Now, when we do the dosage formula, it's important to realize that unless the problem is stated otherwise, you are calculating how much is in a single dose, not how much is on a course of treatment for a patient, but how much you'd be giving a patient at that single time, like when you're giving their medication at a given time. Now, before when we work with conversions, the conversions came from tables. For example, 1 gram is 1,000 milligrams. We used that in the last section on apothecary, or, when we did metric to English, 1 teaspoon is a milliliter. And these are true all the time. They never change. But now our conversions are going to be dealt with as strengths. Strengths do change because depending on the type of drug and the way it's present or way it's given to a patient, it can be different. But you're going to look for your strength. There will be your conversions between the amount of drug and the quantity by looking at either the label or it'll be given in the problem. So, understand that 30 milligrams per milliliter is not for every drug, it's just for the particular drug that you're working with. Or 1 tablet is 50 milligrams is just for a particular drug. It's not for all drugs. Now, if you look at this label, and let's kind of understand what this label means. What is the strength? Well, I look here and I notice that it tells me 4 milligrams. So I know that 4 milligrams is how much drug there is. But if you notice here, this says 100 tablets. That is telling you there is 100 tablets in this bottle, not that every 100 tablets means 4 milligrams. There's 4 milligrams in every tablet. So this means 4 milligrams is 1 tablet, or 4 milligrams per tab would be how it would be written with the fractional form. So just kind of understand when you see these 100 numbers, like the number of tablets, this is how much is in the entire container or the entire bottle. It's not per tablet. This number is telling you the amount per tablet. And again, if you look over here, kind of the fine print, it kind of tells you each tablet is 4 milligrams. Now, these problems can be worked using your dimensional analysis or your conversion factors that we did before, but we're going to focus on doing the dosage formula on this one, which is kind of a new method. Now, keep in mind, you still may have to convert some units. Now, the dosage formula deals with 3 numbers. You have a D divided by an H times a Q. Now, what do each of those stand for? D stands for the desired dose. So this is like how much the doctor orders the patient to have. H is the amount of drug on hand. So, if you look at the label or you look at what's given the problem, how does the drug come? Quantity kind of deals with, how does the drug come? Does it come in 5 milliliter portions? Does it come in a tablet? How does it come? And then this X is just standing for your answer. Now, when you set up your problem, make sure that the unit for the D and the H are the same. For example, if the dosage is in milligrams, the on hand has to also be in milligrams. One can't be in grams and the other one milligrams. And then something to note is when you do your quantity, that's the way your answer is going to come out. So say if this is in tablets, your answer is going to come out in tablets. Now let's look at a problem. First, let's look at this label and find out, what is the D, the H, and the Q. So we got to see, what did the doctor order? The patient needs 50 milligrams. So this is going to be my dose. Now, what you have on hand is what comes in the label. This is what they have on hand at the pharmacy. And if we look, it tells us that there are 25 milligram tablets in here. So we know that 25 is what I have on hand. That's my H, and it comes in tablet form. Now, keep in mind, that does not mean 25 milligrams is 30 tablets. It means that each tablet is 25 milligrams. So on hand, we have 25 milligrams, and it's per 1 tablet. Now, if we set up our problem, we've got to put the D on the top. Let me go ahead and put my 50 milligrams. Forgot to put that. 50 milligrams over what's on hand, 25 milligrams, and we're going to multiply by the 1 tablet. Now, before I do the math, I want to point out, can you see how these will cancel, so the unit you have left is a tablet. Now, most students, when they do these, they go ahead and divide this out first and then multiply by the number here. But you can multiply first, then divide. It's just your preference. I'm going to go ahead and divide this first and then multiply by the quantity that's here. 50 divided by 25 makes 2. And then, so I'm going to have 2 times 1, and 2 times 1 is 2. So my answer is 2 tablets. So a single dose for this patient would be 2 tablets. Now, if we look at this one, it's kind of written in different format. The order is 60 milligrams, so I have it pointed out that is your dose. What they have on hand, this would be like what's on the label. There's 100 milligrams in 5 milliliters. Like, for example, this might be a cough syrup or something that someone would take. There's 100 milligrams in or 100 milligrams of the drug in 5 milliliters. So we'll fill in what we know. We know that the dose is 60 milligrams. What we have on hand is 100 milligrams. And the quantity is 5 milliliters. So setting things up, the dose goes on top. What's on hand goes on the bottom. And notice these cancel, which they should, and we're going to times it by the quantity, which is 5 milliliters. Now, since this is 5 milliliters, I know that my answer is going to be in milliliters. Now, let's go ahead and do the math. We can do 60 divided by 100, which would give me 0.6, and I'm going to multiply that by 5, and that's going to end up giving me 3, and the unit would be milliliters, of course, because the milligrams cancel, and what you're left with is milliliters. Let's try another one. Now, this one gave us those used milliequivalents. Milliequivalents is a number of grams contained in 1 milliliter of solution. And sometimes it's used for these particular drugs. Now, again, we don't have to worry about all of this. This would be more something that will be taught later on in a medical course if you take one. But what we need to look at is the numbers or the quantities. Now, this one says the prescriber ordered, so that's kind of a key word, this 10 milliequivalents PO daily. Now, just remember, PO means by mouth, so they're giving this daily. So the dose is 10 milliequivalents. Now, what we have on hand, we're going to see right here. The strength of this drug is 20 milliequivalents, and the quantity that it comes in is in 15 milliliter quantities. So let's go ahead and set up the problem. We've got 10 milliequivalents divided by 20 milliequivalents, and we're going to times it by the 15 milliliters. Now, milliequivalents will cancel, so I know my answer is going to be in milliliters. Now, doing the math, 1 divided by 20 would give me 0.5, and I'm going to multiply that by 15, which would give me 7.5, and checking back, my unit would be milliliters. Here's another one to practice. Start out, we'll look, the order is 125 milligrams, so the patient's going to get 125 milligrams of the drug. What do they have in the pharmacy, or what does the bottle say? That there is 100 milligrams per 4 milliliters. So setting up my problem, 125 milligrams divided by 100 milligrams, and we're going to times it by 4 milliliters. Now, milligrams will cancel, and doing the math, 125 divided by 100 gives me 1.25, and I'm going to multiply that by 4. And that would end up giving me a 5. And again, the unit would be the unit that's not canceled out, would be 5 milliliters.